Welcome to our Precalculus class for STEM students. Today's lesson is Parabola, definition and its equation. Let's start the lesson with the definition of a parabola. Some of the most obvious objects that are parabolic in shape are the reflector of most flashlights, and the satellite dish. Ever wonder why? The parabolic shape of the satellite dish makes it easy to direct the signal inward onto a particular point, providing high directivity, high power, and low levels of loss. Parabolas, often used in engineering and physics, have many important applications. Hence, it is important for us to study them as they often appear anywhere around us, even in nature. Parabola is a U-shaped plane curve formed by the set of all points, such that its distances from a given point f, and a given line L, are the same, assuming that point f is not on line L. Point f refers to the focus, while line L refers to the directrix, the two important parts of a parabola. Notice that the focus is always inside the parabola, while the directrix is opposite to the opening of a parabola. We also have the vertex of the parabola. It is the point of intersection of the parabola and the axis of symmetry. It is found at the midpoint of the focus and the nearest point on the directrix. The axis of symmetry is a line that divides the parabola into two congruent halves. The axis of symmetry always passes through the vertex and the focus of the parabola. The latus rectum is a line segment passing through the focus, and perpendicular to the axis of symmetry. Parabola can be vertical, which opens upward or downward. It can also be horizontal, which opens to the right or to the left. Say for example this parabola. It opens upward. Its vertex is at the origin, or 0, 0. Its focus is at 0, 2. Its directrix is the line y equals -2. And its axis of symmetry is the line x equals 0, or the y-axis. Note that, if the vertex of a parabola is at the origin, then the focus of this parabola is at 0, c, and the directrix is the line y equals -c. We use c to denote the focal length of the parabola, or the distance from focus to vertex. In this case our c is 2 units. Recall that the distance of vertex to the focus and the distance of vertex to the nearest point on the directrix are the same. Also, although focal length c is a distance, it is important to note that we will be giving c a positive or negative sign. This is important so that it can tell us whether the parabola opens upward or downward. So if c is greater than 0, or positive, then the focus must be above the vertex, and the parabola opens upward. And if the value of c is less than 0, or negative, then the focus must be below the vertex, and the parabola opens downward. Observe that this parabola opens to the right. Its vertex is at the origin or 0, 0, while its focus is at the right, 2, 0. The directrix is the line at the left of the vertex, with equation x equals -2. The axis of symmetry is the line y equals 0, or the x-axis. The value of c is +2, since the distance from vertex to the focus is 2 units to its right, and the parabola opens to the right. In here, the value of c is -2, because the focus is on the left of the vertex, 2 units away, and the parabola opens to the left. Now let's proceed to the equation of a parabola. A vertical parabola, or parabola that opens upward or downward, whose vertex is at the origin, has a standard form of equation, x² equals 4cy. Where c is the focal length, that is positive, if it opens upward, and negative, if it opens downward. So if the parabola has an equation, in standard form, x² equals 4, cy, where c is not equal to 0, then the vertex is at the origin. The focus f, with coordinates 0, c, is c units away from the vertex. Similarly, the directrix is also c units away from the vertex, that is, in an opposite direction to the focus, and is the horizontal line, y equals -c. The parabola opens upward, if c is positive, and downward, if c is negative. Lastly, the axis of symmetry of a parabola with vertex at the origin is x equals 0, or y-axis. Meanwhile, a horizontal parabola, or parabola that opens to the right or to the left, whose vertex is at the origin, has a standard form of equation, y squared equals 4cx, where c is the focal length, that is positive, if it opens to the right, and negative, if it opens to the left. So if the parabola has an equation, in standard form, y squared equals 4cx, where c is not equal to 0, then the vertex is at the origin. C is the distance of vertex to focus, that is positive if the focus is to the right, while negative if the focus is to the left of the vertex. Let's try to find the equation of a parabola, in standard form, given the following. So the given is, the directrix, y equals -4, and the focus, at 0, 4. First, we have to know whether the parabola is vertical, or horizontal. As you have known, the equation of a vertical parabola is x squared equals 4cy, while the equation of a horizontal parabola is y squared equals 4cx. To better visualize the given, we can plot them on the Cartesian plane. This is the directrix at y equals -4. The focus is at 0, 4. Vertex is found at the midpoint between the focus and the directrix. The distance between the focus and the directrix is 8, so vertex is found 4 units below the focus, or above the directrix. From the graph, we learned that the parabola is vertical, that opens upward, because the focus is above the vertex. Hence, we will use the equation, x squared equals 4cy. Also, we learned that the distance from the vertex to the focus is 4, so c is equal to 4. Substituting the value of c to the standard form of equation of the parabola, we will have x squared equals 4 times 4 times y, or x squared equals 16y. The parabola will look like this when graphed. Notice that the length of the lattice rectum is 16 units, if you count from one endpoint to another endpoint. Again, the lattice rectum is the segment formed by 2 points on the parabola that passes through the focus, and is perpendicular to the axis of symmetry. Now, for this given, the directrix is x equals -1.5, and the focus is at 1.50. To better visualize it, we can plot it in the Cartesian plane. As you can see, the focus is to the right of the directrix, so our parabola opens to the right. We will be using the formula, y squared equals 4cx. To find the value of c, we can get the horizontal distance from focus to directrix. So from 1.5 to -1.5, that is 3 units. Divide it by 2, to get c, that would be 1.5 units. Therefore, the vertex is 1.5 units to the left of the focus, or at the origin. Applying c equals 1.5 to our standard form of equation, we have y squared equals 4 times 1.5x, or y squared equals 6x. Notice that, if we are to measure the lattice rectum by counting, it will be 6 units. Now, for the last given, if our focus is at -3, 0, and the vertex is at the origin. Using this given, even if without graphing, we know that the parabola opens to the left, since the focus is to the left of the vertex. Hence, we will use the equation y squared equals 4cx. We also know that the focus is 3 units away from the vertex, and since the parabola opens to the left, then our c is negative. Substituting the value of c, we have y squared equals 4 times negative 3 times x, or y squared equals negative 12x. And this parabola has lattice rectum that is 12 units. Now, regarding the lattice rectum, what pattern can you take from the previous examples, related to the length of the lattice rectum? The length of the lattice rectum of a parabola is equal to 4c. In summary, the equation of a parabola in standard form, if its axis of symmetry is vertical, is x squared equals 4cy. If it opens upward, then c, our focal length, is positive. The focus is c units above the vertex, and the directrix is c units below the vertex. On the other hand, if the parabola opens downward, then c is negative. The focus is c units below the vertex, while the directrix is c units above the vertex. Meanwhile, the equation of a parabola in standard form, if its axis of symmetry is horizontal, is y squared equals 4cx. If it opens to the right, then c, our focal length, is positive. The focus is c units to the right of the vertex, and the directrix is c units to the left of the vertex. On the other hand, if the parabola opens to the left, then c is negative. The focus is c units to the left of the vertex, while the directrix is c units to the right of the vertex. What if the vertex of the parabola is not on the origin, but on, let's say, hk? A parabola whose vertex is at hk, and has a vertical axis of symmetry, has an equation in standard form as x minus h squared equals 4c times y minus k. In this given parabola, the vertex is not on the origin, but at 3, 2. The focus is above it, at 3, 4, while the directrix is at y equals 0 or the x-axis. The distance from vertex to the focus is still denoted by c. If it opens upward, c is positive, and the focus is above the vertex. If it opens downward, c is negative, or the focus is below the vertex. Going back to this given, if we want to find the equation of this parabola in standard form, we only need to know the value of c and the vertex. So for this, the distance from vertex to the focus is 2 units. And since it opens upward, then the parabola's c is positive 2. Our vertex, as seen on the graph, is 3, 2. Supply these given to our standard form of equation for vertical parabola, which is x minus h squared equals 4c times y minus k. This will give us x minus 3 squared equals 4 times 2 times y minus 2, or x minus 3 squared equals 8 times y minus 2. Next, this parabola is still vertical, but it opens downward. If we want to find the equation of this parabola in standard form, we still need to know the value of c and the vertex. So for this, the distance from vertex to the focus is 3 units. And since it opens downward, then the parabola's c is negative 3. Our vertex, as seen on the graph, is at 4, 1. Supply these given to our standard form of equation for vertical parabola, which is x minus h squared equals 4c times y minus k. This will give us x minus 4 squared equals 4 times negative 3 times y minus 1. Or x minus 4 squared equals negative 12 times y minus 1. For horizontal parabola whose vertex is at hk, the equation in standard form is y minus k squared equals 4c times x minus h. Again, c refers to the distance between focus and vertex. If the parabola opens to the right, then c is positive, or the focus is to the right of the vertex. But if the parabola opens to the left, then c is negative, or the focus is to the left of the vertex. Now let us try to determine the equation of this parabola in standard form. As you can see, it opens to the left. Hence, its c is negative. And since the focus is 3 units away from the vertex, then c equals negative 3. After finding the value for c, we now find the coordinates of the vertex. In this case, based on the graph, the vertex is at 2, negative 2. Supplying these given to the equation, y minus k squared equals 4c times x minus h, we will have y minus negative 2 squared equals 4 times negative 3 times x minus 2. Or y plus 2 squared equals negative 12 times x minus 2. In summary, the equation of a parabola in standard form if its vertex is at point hk, and it opens upward or downward, is x minus h squared equals 4c times y minus k. If it opens upward, c is positive. Its focus is c units above the vertex, while the directrix is c units below the vertex. Meanwhile, if the parabola opens downward, then c is negative. The focus is c units below the vertex, and the directrix is c units above the vertex. And if the parabola opens to the left or to the right, with its vertex at hk, then its equation in standard form is y minus k squared equals 4c times x minus h. If it opens to the right, c is positive. Its focus is c units to the right of the vertex, while the directrix is c units to the left of the vertex. Meanwhile, if the parabola opens to the left, then c is negative. The focus is c units to the left of the vertex, and the directrix is c units to right of the vertex. Let's practice. Try to solve for the following. Get your pen and paper, and pause the video to try it yourself. Resume the video to check your answer, once you're done. To find any equation of a parabola in standard form, we must know its vertex and the value of c, or the focal length. In this problem, the vertex of the parabola is at 4, 3. Since the focus is 2 units above the vertex, then our c is positive 2. Because c, or the focus length, refers to the distance of the focus to the vertex. And since the focus is above the vertex, then c is positive, which means the parabola opens upward. Now to get its equation, supply the given vertex and the value of c to the equation, x minus h squared equals 4c times y minus k. The equation becomes x minus 4 squared equals 4 times 2 times y minus 3, or x minus 4 squared equals 8 times y minus 3. Were you able to get the same answer? Now, for the next problem, the vertex is already given, at negative 2, 1. The directrix is 4 units above the vertex. We know that if the directrix is 4 units above the vertex, then the focus, must be 4 units below the vertex. Hence, our c is -4, and the parabola opens downward. The standard form of equation must be x plus 2 squared equals 4 times -4 times y minus 1. Or x plus 2 squared equals -16 times y minus 1. In this given, we don't have both the vertex and the value for c. Instead, we're given with the focus at 1, 3, and the directrix 6 units to the left of focus. Since the focus is to the right of the directrix, we can say that the parabola opens to the right. To find the vertex given the focus and the directrix, we just need to find the distance from the focus and to the directrix and divide it by 2, since the vertex is in between them. We can plot them on a Cartesian plane, to better visualize the given. Since the distance from the focus to the nearest point on the directrix, if we are to count it, is 6 units, then, we can just divide it by 2, to get the distance from focus to vertex. The distance from the focus to the directrix is 6 units, hence, the vertex is 3 units to the left of the focus, or at -2, 3. With this, we were also able to find the focal length c as +3, since it is the distance from the focus to the vertex, and the parabola opens to the right. After finding the vertex and the value for c, we can just substitute them to the equation in standard form of a horizontal parabola, which is y minus k squared equals 4c times x minus h. Substituting our given, we will have y minus 3 squared equals 4 times 3 times x minus -2. Or y minus 3 squared equals 12 times x plus 2. Were you able to arrive at the same answer? Now, for the last problem, our directrix is at x equals 5. The axis of symmetry is the line y equals 3, which tells us that the parabola is horizontal, and the vertex is 3 units to the left of the focus, which tells us that the parabola opens to the right, because the focus is to the right of the vertex. Based on the given, vertex is 3 units away from the focus. Hence, our c is +3. And since the focus is 3 units away from the vertex, then, the directrix is also 3 units away from the vertex. If the directrix is at x equals 5, then we can just count 3 units to the right of the directrix to get our vertex, provided that it lies on the axis of symmetry. Why? Because the axis of symmetry always passes through the vertex and the focus of the parabola. Therefore, our vertex must be at 8, 3, the point on the axis of symmetry, that is 3 units to the right of the directrix. With c equals 3, and the vertex at 8, 3, we can now determine the equation of this parabola in standard form. Substitute the values to y minus k squared equals 4c times x minus h. We have y minus 3 squared equals 4 times 3 times x minus 8. Or y minus 3 squared equals 12 times x minus 8. Did you get the same answer? If not, you can go back and watch the explanation once again. Tune in again next time for other challenging problems related to parabola. Thank you again for watching. Hope you learned something from this video. If you do, kindly give us a like, subscribe, and hit the notification bell to get more lessons in mathematics for senior high.